So again, a happy moments for you all. So here we will be sharing, there is a very good two presentations in the morning. One is by Dr. Sanath, a highly experienced presentation covering all the design parameters of concrete, steel and composites. He have made a lot of insights about comparisons of various things. And Sanath, after Sanath we had Arvind, who had a wide range of basically on bridges. So he poured a lot of thoughts. I think after a long time I am seeing a very seasoned engineer, Mr. Arvind. I am so happy to be hearing his session. So now it is going to be very interesting one. I am not going to bore you with any of the codal parameters. I am not going to bore you any of the your formulas. Okay, we are going to see how a composite structure is going to get executed. Okay, so that's going to be there. So these are the major contents which we will be going through. Majorly we will be rushing through steel concrete composite since already 2 sessions have happened. It's like everyone is coming and telling good morning. Yes, we also come and tell good morning. So similar to that steel concrete composite, I will have an overview. Then we will talk about one important parameter which Dr. Sanath have lightly touched, which is on the joints. I will just touch on the parameter joints. Then we will talk about fireproofing, which Arvind have already covered. I will also rush through that. Then we will talk about the major topic, which is the composite construction challenges. When we execute the project, what are the challenges we face? So we all know that the concrete is good in compression and the steel is good in tension. That's why we try to take the advantage of both the things and we are trying to incorporate as a composite. So we all have seen, so it has an increased strength and stiffness, reduced deflection, economy, faster construction, many other parameters. So this is another one which even our Minister Garu have touched upon. Why we have to go with steel? It is sustainable. It is a green material. Whenever we want to think about the future, yes, steel is the future where we can reuse. It has less energy consumption. When we talk about concrete construction, the major challenge what we have in concrete construction is the manpower going to get deployed in that particular construction. There are thousands of manpowers for every IT building or every huge jungle of construction is going to be there. Whereas it is going to be about 15%. It is when you take 100% for concrete, when you take steel building, it will be only 15%. When you take composite, it will be around 30% of the manpower only will be there. So the major two drawbacks is corrosion and susceptible to fire. So both have been addressed. So we will also have a brief about this in this particular presentation also. So what are the various parameters we can see is, we can see on the grillage foundation, we can see. So grillage foundation, you can see there is a, today itself there is another session coming in on the detailed design of the grillage foundation. You can, whomever there in terms of substructure enthusiast, you can listen to them. Then in terms of superstructure, we can have the composite columns, we can have the composite transfer trusses. These are very unique transfer trusses where whenever we have some architectural challenges, where architecture throw a lot of challenges to the structural engineers. They put a lot of highly complex geometry. So those type of things, by use of steel, we can have it. So what are the key components are steel beams, then concrete slabs, then shear connectors and deckings. I'm not going to bore you higher since Arvind have covered everything. So I'll just skip this one. So only one thing which I want to stress, which is another information which Arvind have not given is, there are two types of deckings. One is the normal decking, another one is deep decking. So there are two types which he have covered is trapezoidal and re-entrant. Re-entrant are the one which is nowadays architecturally also there are people are happy to go with re-entrant corners. The deep deck, why we have to go to deep deck is When the span is this particular span, we have 60 mm deep normal trapezoidal deck, then we have 80 mm. This can span to a maximum of 3.5 meter. When I want to span my metal deck to 5 meters, even 6.5 meters, we can go with deep decking. So shear connectors, I am just skipping it. So there are some precautions has to be done. One is the beautiful one, which has to be, any engineer has to know about, is a bend test. So every 2 studs for every 100 studs, we have to do this bend test. We have to blow it by a hammer, and that particular shear stud should not have any cracks in terms of the weldings. There should not be any cracks. So there are various types of composite columns are there. Today evening, Madam Sultana will cover the design part of that. I'm not going to into the composite columns. So in terms of various stages of composite slab constructions are, the first one is lay the deck. Then we will be having shear stud. That's what we have seen in the previous chapters. Then we have to lay the rebar. Rebar can be either welded rebar mesh or it can be a conventional rebar. Then we have to pour the concrete. Okay. So the next part. So far I have rushed. Okay, I have not. I have made you to recollect what the first 2 session gentlemen have given us. So the next one is on the joints. Why joints are so important is, whenever we talk about simple connections, hinged, fixed, we all know that when both ends are fixed, it will behave differently. When one end pinned, another end hinged, it is called a simply supported beam, it will behave differently. So that means that when as an engineer, we don't have a knowledge on the joints, how it going to be connected, then whatever the design we have made, it is going to be highly futile. So that is where the major cause, what I personally see in terms of many failures, that is one of the major reason. So in terms of columns, we have fixed base, we have pinned base. So in overall, we will see in fixed base, we have to arrest all the 6 degrees of freedom. What are the 6 degrees of freedom? We have axial force, we have shear force in one direction, shear force in the other direction, then all 3 directions of moments. So all these things, when you could be able to arrest in this particular type of connection, either it can be a column, it can be a beam, it can be whatever may be the element. When you could be able to arrest that, it is called fixed. When you are allowing all the moments to pass through, when you are allowing only the shear to take up by this particular joint, then it is a shear connection. So every time we in our analysis, we do all these type of support conditions, we have to make sure that it is done proper. So these are moment connections. You can see the first one where the moments or the axial forces are carried by the flanges and the web will carry the shear. So when you arrest the web, it is good enough to carry the shear. When you arrest the flanges, it is good enough. It will be carrying the moment. Fine. So most of the primary to secondary beams will be of simple connections because that's where the composite effect comes in. As Arvind have clearly pointed out the usage of shear connectors, when the shear connector is there and the moment is there, there will be a distribution will be there where when it is a pure pin connection, then the composite will be 100%, the steel beam will be composite. So you can see now there are different types of connections which I want to give you a thought process. So CFTs, normally we come into CFT. So CFTs will be having shear lux inside. Madam Sultana will be covering about the design of parameters of that. So this is a typical column CFT to column moment connections where the one beam stub will be welded and there will be a moment connection will be there. So this is another view where we will be having a diaphragm plate which will be passing through and through or even outskirts. This is a very good shear connection. It will be, as I told earlier, it will be connecting only to the webs. It is a typical embed connection where it will be either with the shear studs or it will be with the cogged bars. We can connect the embed plate to the concrete. So this is one connection which I want to have you more attention on this, because whenever you talk about encasement of concrete, how the sequencing of the concrete encasement will happen is, you have to erect a steel column, then you will be having your form work. It is not CFT. You will be having your form work. Then you will be pouring concrete. When you are pouring concrete, before you are pouring concrete, when you have your form work, when the beam is getting inside the form work, you will be having a lot of difficulty in terms of making the form work around the beam. So the simple methodology is, take the fin plate outside. Make sure that you design the fin plate. It is going to be a very long fin plate. You have to design the fin plate accordingly. It takes care of the torsion. When the self weight of the beam and the concrete it is there, you have to take care. Fine. Now fireproof, I will just fast forward this since Aravind have clearly covered this. There are majorly two types are there. One is cementitious, another one is intumescent. Fine. So one particular pros and cons which I want to highlight is intumescent is highly expensive, which is about 5 times expensive. But why people want to go with intumescent is, it is architecturally, it is very good. Okay, now we are coming on to the subject. So we are going to throw some light on how the composite constructions are made, what are the different challenges while we are making a construction, what is that we are going to face. There are 3 types of challenges I am just dividing into. One is detailed design challenges. The design is made. Yes, the design is made. Then we are getting into the detailed design parameters. Yes, what are the different types of detailed design challenges are? First one is the geometry and setting out challenges. So this is statue of unity. You can see how much is the difficulty in terms while we are doing the detailed design. There are geometrical, we have going to be having a difficulty. And connections, as I briefly told about the various type of connections, per node we have encountered around 16 to 17 type of connections coming into, and in different planes. And this is over the bearing. And the pre-cambering. Pre-cambering is highly explained by Aravind. I will just reiterate again. Whenever there is a problem in terms of serviceability, strength is governed, strength is happy, I am happy with the strength. But I have a problem in terms of governing, in terms of serviceability, in terms of deflection. So what I will make in terms of very large span it will happen. What I will do is, I will make a upward camber. He have clearly explained upward camber, that is called pre-cambering. So once it settles, it will settle to the original point or within the deflection limit. What is the challenge here is when it is a curved shape. When it is a straight, it is fine. When it is a curved shape, it is in a proper radius. When it gets down, then we have a challenge. So there are challenges in the detailed engineering in terms of accommodating the MEP openings. So there are a lot of MEP openings will be there. We have to accommodate those things. Sorry. And another one is on the rebar accommodation. Okay, whenever we talk about, we all talk about highly about composite construction. We have steel inside, we have concrete rebar outside, but the congestion of the rebar is very high. You have to get into the field to know how the congestion of rebar is there. And you can see in these photographs, this is a transfer girder. I have shown in my initial slide, I have shown that how the transfer girder will be. So in the transfer girder, there are 2 plates, say 60 or 80 mm thick outside. Then inside we have the rebar. Then inside it, it is a CFT composite girder. There will be a concrete will be poured inside. So these are another parameters where in terms of even the columns, we are facing problems in terms of coordinations. So deck we have shear studs we have, but what will be having, we have shear stud in terms of a deck which is spanning in a, not in an orthogonal direction, in an angular direction. So we have to place in terms of detailed engineering. All these things, whatever we are talking about in the room, in the detailed engineering, we have to close it out. And this is incorporation of the facade elements. So all these things which we are talking about in terms of so far, in terms of detailed engineering, which we have to close in terms of the office works, that is called nowadays BIM. And more in detail, Mr. Ravikant, my sweet friend, will talk about this one in tomorrow by 1 o'clock he will be talking about. So how to conquer all these challenges. He will have a detailed study on this. So tomorrow don't miss that chapter. So now we will get into the fabrication challenges. So we have seen the challenges which we have faced in the detailed design. Now we encountered all those things, we have resolved that. So what are the things we are having in fabrication? So this is one of the challenging projects which we have worked in. This is called Qatar National Museum. This is in the shape of a desert flower. It is by an architect. So yeah, stylish proverb will be there. Every architect's dream is a designer's nightmare. So it is inspired by a desert flower. So that is the shape of the structure, and the King Qatar government also highly appreciated the design, and it's the nightmare to get things done in terms of coordination, in terms of fabrication. You can see the central node and how many members getting connected. So it has to be properly, it has to be set outs has to be there, proper jigs has to be there. Then once it is made, then proper welding. Welding also has to be in sequence. You cannot weld in one direction itself. When you have plates of, say, 6 mm, it will have distortion. When you have plates of, say, 100 mm, it will also have its own issues in terms of you have to pour that much of weldment. Then the next challenge is the curvilinear structures. Curvilinear structure in terms of fabrication, yes, when it is within the rollable parameters, radius, when the radius is high, how much bigger the radius is, we can do a rolling in the roller itself. When the curvature is completely different and the architecture is looking for that curvature, then we have to, many times we have to go for a segmental one. So this is New Doha International Airport, the Qatar one, which is one of the biggest airport in the world. And this is a smaller yas canopy. The next one is on the geometrical fit. We all talk about, especially in terms of bridges, we'll talk about we have to make a pre-assembly in the yard. There should not be any issues in terms of while we are getting into the site. Since site will have an adverse weather conditions, it is not the factory. And there are many composite constructions, we have challenges is, there are many composite construction happening, fabrication at the site itself. But it's not the proper way. It has to be there as a controlled environment. That's where we can control all these challenges. So it is one of the parameters where it has to be ensured in the factory itself. So this is again New Delhi International Airport. You can see the human standing there. Okay, so you can see this is one of the girders which is there. So this is the Indian projects where the complete boiler structure has been completely assembled on the floor and it has been verified. As I told in the detailed design, also the MEPs will be, many times will be inserted inside during the factory stage itself. So this is one example. This you can see the rebar couplers. You can see for the continuity of the rebars, for the slab rebars, whatever it is clashing with this particular beam, you can have the rebar getting welded and you have the coupler. So all these things will be also part of the factory. These are the facade cleats. Another challenge is AESs. So many of the, currently we have architectural AESs means architecturally exposed steel structure. So there are various parameters of AESS is there. There are basically three types of parameters, how smooth the finish has to be. So what are the other challenges in terms of fabrication is, we have the shear connector installation, whether to be there in the site or in the shop. You have in the shop, and when you go to the site, when your decking is not, when the deck sheet is not cut to the proper one, you might have a challenge. So you will be forced to weld the shear studs at the site. Then the surface preparations, whenever you have a painting, you have to have a proper surface preparation. When you have even your vermiculate or the cementitious coating, you need to have your surface preparations. And tight tolerance. Many times, like how the front runner is the architect and the last person is the facade. So facade also will be the brotherhood of architect. So designers, what they will ask is, they will ask for a very stringent tolerance in terms of facade cleats. They will be asking plus or minus 2 mm. Okay? Fine. So we will get into the erection engineering challenges. So the first one is on the shape and size. As I told that the architectural will have. So the first one is the Burj Khalifa and the next one is the Kingdom Trade Center in Saudi. So you can see the top necklace shape structure at the top. It is a completely steel structure. This is a football stadium in Qatar. And these are other few types of one, and the one you might have very fascinated is this Dubai wheel, and this is a metro station, and this is part of Yas Mall. Okay, so the shapes are having structure. So the next one is stability. As engineers, I want you to further concentrate furthermore on the stability. We all talk about designing the structure. Designing the structure is very good. So this particular structure is designed. Let us not take it as a huge building. Let me take 1, 2, 3 columns supported at the top by a beam. Okay? How we will design, what is the parameter we will take? One end fixed, other end is pinned, or other end is fixed. Say we assume that the top end is pinned. So what is the buckling parameter we'll take? We will not take 1 or we will not take 2. But how we are going to construct? When we are going to construct it, it is going to be having a, now it is going to be, this column is going to be a cantilever. So one end fixed, other end is completely free, which means that the parameter is 2 now. So it is in a bigger stage I am explaining. So even the smaller parameters also we have to design. There are a lot of enthusiastic engineers has to come in. While we are designing important structures, we have to have a think process of how it is going to be constructed. So the stability will be arrested by means of temporary towers, guy wires, and lateral arrestor frames. So even in terms of deflections, we will be having a problem in terms of erection. During erection, we will be having a deflection, which we have to analyze. We have to make sure that the reverse precamber has been done. There is a preset has to be done. Then we have to fabricate. So there are different stages in terms of loading. We have self-weight alone will be there in the erection stage, where will be permanent structures. It will be there with the complete loading. The loading parameters and the solidity ratio is completely different. There we have complete facade we will be having. Here we don't have a facade. It will be completely exposed. So the design is completely different when you do a erection engineering. And the next challenge in terms of erection is the crane. So we have seen the cranes. There are elements, even 15 tons. There is one particular temple which we are currently in discussion. The element is about 45 tons. We could not able to cut short any of the element. It is a 45 tons. It has to be lifted. So the crane plays a major role in terms of while we are constructing. And the access towards the site, we have to make sure that the access path is proper. We have to take the assemblies there within the site. We have to take it up. This is nothing but Dubai Mall. This is constructed in between 2005 and 2010. And the next challenge is on the schedule and cost. The various parameters, whatever we have seen, it's also linked with schedule and cost. So we will see some innovative methods of erection. The first one is temporary tower method. So this one, hope most of the people whomever coming from Hyderabad will be knowing that. Even our Minister Garu have explained about the technology hub, which is there few kilometers away from that. When we started the inquiry of this particular project, we thought that this government is not going to build this project. By seeing this architectural element, I thought that everywhere it is cantilever. Government, why we have to spend this much like? But the motivation, the visualization of the government is such that they have to build such iconic towers. So when we have to build such iconic towers, we have to make sure that the erection engineering is done proper. So this is, you can visit few kilometers away from this particular building, it is there. So this is the final finished one. So this is during the erection engineering stage. Everywhere we have the temporary structures. It is completely designed. It is not just a temporary structure getting propped. When you prop something, okay, I have a structure, I am propping something, I have put my load inside that. But when I have to take this one, okay, I have to take the prop outside, means I have to make sure that I found a proper methodology to lift the structure back so that I can take this member out. So that is called, you cannot just like that see that it is a temporary tower. You have to see how the temporary analysis has to be done like. So this is the real-time photograph of the construction of the technology hub 2. So this is after removing of the props. This is another one, you have seen this in the pre-assembly stage, you have seen, so this is also done by means of temporary towers. The another interesting methodology is the strand jacking. Now we have seen towers, temporary towers, the another one is strand jacking. So this is a very beautiful structure which is this called Atmosphere. This is in Kolkata by Forum Group. It is a 30-story building. Over 100 meters, we have about 2,800 tons of material has to be there. When I have to construct by the earlier method, say temporary tower method, I have to prop from the top to bottom. That's how previously it has been done. Okay? But now what is the methodology? What is the new methodology we have is the strand jacking. So the portions which is there at the end, it will be constructed over the top of the building by means of the cranes. Then the middle portion will be assembled in the ground and it will be lifted by means of strand jacks. The major thing which you have to understand in terms of engineering aspect, when you have this much amount of tensile load, then you will be having a huge uplift here. Here you will be having a huge uplift. That means that during the main design itself, you have to do the required holding down assemblies inside the concrete element itself. So this is a real-time photograph. This is done in 2007 August. So this is the complete steel structure is finished, over which we have the swimming pool, over which will the golf club. There is a highly landscaping, and it is owned only. It is not a public property. It is a private property. It is a 30-story building, both ends. So it is a 60 families. It is for the 60 families. Another one is the strand jacking, and there is a sliding. So when there is no access, taking the material, I told about the site access, I told about you have the crane access. So this is my structure, I have to erect my structure here. I have to erect my structure here. but my crane will come only here. I have my access only here. What I will do is, I will completely construct or hold all the structure here, and I will make sure that it get moved, slide across vertically or even in an angular manner. So this is one of its type. This is stand jacking and tilting. So along with the stand jacking, we have to do a tilting also. This will be done for lighting structures. Okay. So this is another view of the lighting structure, and this is a canopy where again a tilting method has been followed. And another one is temporary bridge method, which I think Aravind sir might done it day in and day out. There is a temporary bridge will be done again before the original bridge is going to be built. This will be carrying only the self weight of the structure which is there above, so that the span will not be having any problem. So this is the launching method which I told that we will be assembling and we will be just pushing, launching that inside that. It will be also called as incremental cantilever method. So this is, I told about the sliding along the curve. So all these things does not have the crane access. So it has been assembled here and it has been pushed over. Every gantry has been pushed over and it has been done inside. So this is also in Dubai Mall. Sorry, I just switched it back. So this is the closer view of how it has been pre-assembled and how it has been slided along the curve. Yes. So there are various other parameters. We have to see how the bearing surface has to be there while we are sliding. So those things. So hydraulic jacks to push the frame. What are the other challenges we are having is the structural stability we have seen, and alignment and leveling, there is another one. Then concrete pouring, yes, there is a concrete pouring, there will be an issue. And placing of deck, we have seen. And the coordination between each and every trades, that is going to be there. And in terms of how the codal provisions for all these composite construction, tomorrow morning you will be hearing from Hariom, you will be hearing in terms of codal provisions. May I have another 10 minutes? Or I rush through? Fine, okay. Fine, so that's all. This is one which I want you to see. This is from our nearby state or from our neighborly one. This is Amravati. You can see the temporary build, the structures are highly unique, and India is highly getting into the next generation mode. And the structure, whatever you are seeing, is the secretariat buildings, HOD towers, are completely of diagrids. I will quickly run through, 2 minutes, I will quickly run through the one. I just want to introduce about the diagrids, okay? I just make this like a director cut. It is like the film has to get completed now, but if the director wants to have that, it will get prolonged. So another few minutes, I'll just rush through. You will have a glance of what is called diagrid. Since it is going to come, the India is going to see this particular 4 towers are going to get built by diagrid one. So I will get an example. Okay, this is a capital gate tower which is done by diagrid structure. This is one beautiful structure where we have inside diagrid, we have outer diagrid. This is one of the structure which is there in Guinness Book for his 18-degree inclination, which is more than the Pisa. Pisa is by means of accident. This is by means of purposeful made. Okay, I'll just rush through. Key salient features, 35 floors and 15,000 cubic meter of concrete. There is about 13,000 tons of steel. And the die grid elements of 822 elements, and every element approximately it is about 15 tons. So I'll just give you the plan. So this is a plan, okay? You have the core wall inside a concrete core, and you have an internal die grid here. You can see a die grid structure, and there is an outer die grid structure. So by means of die grid structure, majorly we are eliminating all the columns. So that is the beauty in terms of die grids. So I will just run through. Only thing, my slider has to help me. I'm not going to get into the videos of that, so don't worry. So in terms of foundation, it is a very deep foundation. It's a piling has been done. In the structure, right below the structure, also where we are going to encounter the moment. Both sides, there's a huge raft is there, and we have done the piling. And we have the jump form, automatic climbing jump form is there. Every 7 days, one floor will be jumped. So pre-cambering is not only for the building. Pre-cambering also, or not only for the element, also for the building. Like these type of buildings where we are encountering a huge load on the other side. The core wall itself have been designed, engineered in such a way it has been preset in the opposite direction by 350 mm, so that after construction, while the self-weight, while the structure is constructed, it will attain its straight position. So also the pre-tensioning inside the core wall has been done. So these are some of the challenges which we faced by means of the connections, work points. So similar one which we are going to have in the Amaravati building also. All these similar connections are going to come in Amaravati. Okay, Amaravati, if you take, it will be about 600 to 800 mm hollow sections it is going to be there as part of the die grid. About 20 to 45 mm thickness of plates is going to be there. Okay, fine. Fine. So in terms of assemblies, we have to make sure that since it is not vertical, it is going to be a diagonal shape, diagonal one. So diagonally, it has to be proper, erection cleat has to be there, it has to be hold down, and proper welding has to be there. And wherever there is a sliding arrangement is there. In Amaravati also, we will be having some axially released members we have. So we will be having a long slotted holes will be there. So these are long slotted holes to allow the axial forces. So there are embeds which will be on a different angled embeds will be there. So this is a typical die grid assembly will be there. This is a typical drawing where the center portion will be a punch through and it will be stiffened by means of a heavy thick plate. I will show some of the photographs of the die grids. So you can see the die grid on the left and the connecting elements. So this is the analytical model, Tekla model of that. You can see the outer die grid and inside die grid. Also there is a swimming pool is there. So these are the die grids. Okay. So these are the joints which I emphasized. At the node point we have punch through plates which is making sure that all the plates are getting welded to it. And we have the erection cleats getting proper. So these are some of the views and the real-time view of the die grid structure. So I'll just, there are facade cleats also, everything has been coordinated and it has been made. These are the construction photographs of the die grid. So external diagram of 600 mm and internal diagram of 400 mm circular dia was there here. So you can see the internal diagram. It is basically in terms of taking care of the lateral load resisting. Now also in the code we are talking about multiple elements taking care of tube-in-tube concept is nothing but this is the one. So these are the top view of the diagram structure. At some plans, it will be a triangular shape floor plan will be there. At some time, it will be a circular one. Okay, so these are the diagrams. The weldings are going to be very key. It is going to be a controlled one. There are various other elements like floor beams and all is going to be. So this is a cantilevering swimming pool structure which is projecting outside. You can see there is a temporary structure. You can see the element is lifted as if 7 so that there is no need for going and connecting at the last point. So that this is being brought like this so that a minimum access required here. No, only thing is. Shall I have my pointer? Okay. Can you just run through the slides? Yes. Go ahead. Yes, stop here, yeah. Fine. So, to concluding remarks, we have to go with 3D BIM modeling, clash detection. That has to be done every time when you do a composite structure. We all talk about very beautiful things, but the thing which we have to take more caution in terms of 3D BIM. On your paper work, you have to be very clear. And conduct mock-ups, validate the sequences of the complex joints. All the complex joints you have to make sure that you have done. And prefabricate the components, reduce the on-site work. Make sure the quality checks has been done, okay? Composite construction has a lot of benefits. But if it is not done proper, then we can screw up ourselves. So let us make sure that we get into a new technology with high thought process, okay? Everything is there in the world before us, okay? Only thing is we have to be equipped enough to carry that. Okay, with that remark, I just conclude. Thank you, everyone.
Thank you very much, sir. And we will just take 2 questions very, very quickly, if at all there are any. Anybody having a question, please quickly identify yourself.
That earlier diagram section, you did site welding or all are bolt nut connection?
It's had site welding.
Site welding, any preheating challenges of preheating?
Yes. Whenever there is a higher thickness member we have, then there will be a preheating has to be done.
So how you are controlled that site? It is very challenging to do the maintaining the heating?
Yes, we have controlling devices are there, but in that is not a huge challenge in terms of controlling the temperature even at the site. Yes, it requires proper trained laborers, okay, but it is not a challenge there in terms of
maybe over the temperature over there it may be a not, but here in Amravati it will be there, I think. We have some cold.
Only thing we have to have a skilled labor and we have to have the technology to have the control.
Any crack in the welding you observed? Any challenge?
Yes, there are parameters will be there. Cracking will be happening in 2 cases. One is when you don't use a Z grade. We all have seen about different types of grade. There is one parameter called Z grade, Z15, Z25, Z30 it is there. Which that when the rolling mill itself, the grains have been made as such, it has been made not in a sheet manner, it will be made in a diagonal manner. Okay, that is called a Z grade material. You have to make Z grade material when you are going for higher thickness material so that the lamellar tearing will not happen. Also, in terms of weld, you have to make sure that the weld is formed by means of sequence. It is not just pouring a weld at one location. So once you follow that, then will not be a problem. And you have to use a proper welding electrode. between the materials.
Thank you.
Yes, there is one thing called as locked-in stresses, and another one is stress relieving. We have to make sure that we analyze how much is the stress. One is the locked-in stresses, which will be happening when we construct not in the manner we have to supposed to do or as per the designer. So the locked-in stresses is more important. I completely agree. I wanted to touch that, I just forgot. So while we are analyzing, locked-in stresses are so important, which is not getting emphasized in few of the engineers over here. We have to make sure that locked-in stresses are calculated, and we have to make the engineering there.